Hey everybody, this is your Pre-Cal 6.3 video on properties of trig functions. So trigonometry from the Greek word trigonon, which is triangle, and metron, which is measure, involves studying your lengths and angles of triangles. So think of trigonometry triangles. So make sure you try it, trigonometry. The field emerged in the Hellenistic world during 3rd century BC from applications of geometry to astronomical studies. And they noticed the sides of the right triangle and the angles have fixed relationships. Like if you know at least one side and one angle, then everything else can be determined algorithmically, which is the same as algebraically. And then that turned into trig. You can read through most of this. Well, you can read through all of it yourself. But the main thing is your objectives are to be able to determine your domain, range, and period. So about that, the period is a distance. And when we think about it, it's like for the sine graph, it's that, which is 2 pi. It's either the middle to the middle, or from the top to the top on that same graph, because if I extend this down, you can see it's actually the same graph. So it's a distance, and so for sine or cosine, sine, cosine, cosecant, secant, all have period 2 pi, whereas tan and cotan have period pi. So how you can remember that is it's one complete wavelength. It can be from middle to middle, top to top, or bottom to bottom. So when we go to our graph, make sure you're in radian mode. So I got to flip this. And then here's your sine x. Now, at the moment, I'm from -10 to 10, but there is what they call a trig window. So if you go to window and then go to trig, which is number 8, this is showing you 2 periods worth. It's showing you -2 pi to 0 and 0 to pi. But you can see that, like, if you just do this side, that's going to be 2 pi units. If you take off this and this, that's 2 pi units, because you're going from there to there. Wait, did I do that wrong? I just did 3 pi. If you go from top to top, that'd be 2 pi. If you go from bottom to bottom, that'd be 2 pi. If you go from middle to middle, either there or there, that's 2 pi. Now compare that to tangent. So if we go to trig, then go to tan, your asymptotes are going to happen a lot more often. So every pi units, or every about 3 units, there's an asymptote. So how you could remember that is when I do this, make it a relation. I'm going to make one of them x equals 0, which is straight down the middle. Because it goes through the origin, I probably shouldn't have done that. I should have done pi halves. Make this one pi halves. So there's that. And then make this one 3 pi halves. X equal 3 pi over 2. And so then we have that. It's the blue one and the red one that are vertical. And think about 3 pi halves minus pi halves is pi. 3 pi halves minus pi halves equal 2 pi halves, which is pi. And so that's the period for tan and cotan. Now, we're also going to be talking about domain and range quite a bit. And here I tell you, you can change your X scale on the graph and change your table to pi fourths like we did before. So like if we did menu, table, settings, right now it's just random, but if I go to menu, table, settings, make sure your table start is at 0 before you change your step to something, because otherwise you'd be off a little bit and it doesn't make sense. But here I want pi halves, and then you can see it's going between 0, 1, 0, -1, and so forth. So I think when you do pi fourths is when it gives you like the little error message. Well, it's not really an error message, but it's e to the negative number. If I make this pi fourths, yeah, it says -1 e to the -13, which you need to just think as 0. So it's like 0, 0.7, 1, 0.70, -0.7, -1, then bounces back up to -0.7, then to 0. Again, if it's e to the negative number, then it's going to be 0, whether it's positive in front or negative in front of the whole number. Now, I'm just talking about e to the negative number, so that'd be like point and then 12 zeros and a 3. So as long as it's e to a negative number, you can think of that as 0, and it's just going back and forth. So these are just your properties, which we've talked about before, and we'll get to these on the problems. The smallest number is called the fundamental period. So like the normal period for these are 2 pi, and for tan and cotan is pi. It's periodic if it repeats. And then here we're just talking about the radius. Okay, let's get to the problems because I know that's the most useful part. So to start with, I have a problem where it says exact, and that means it's going to be one of the 0, pi 6, pi 4s, pi halves, or thirds, pi halves, or multiples. So that means use your unit circle. So if you do a similar question, it's going to have one of these angles. So what I need is I need my unit circle for 7 pi 6, because what I like to do is I have my angle, and then I need to know the ordered pair. So for 7 pi 6, that's over here, and my ordered pair is negative square root of 3 over 2 and negative a half. When we're doing cotangent, that's x over y. You can remember that if it's tangent, it's y over x, but this is x over y, and so you cancel your negative square root. You cancel your negatives, cancel your 2's, and it's basically square root of 3 over 1, which is square root of 3. For this one, we have 13 pi over 3. So the main thing is we need to know what 2 pi is. 2 pi over 1 equal, let me just say x over 3. So if you set a proportion like this, then you can make that 6 pi. You're just doing 2 pi times 3 is 6 pi, and then divide by 1. So in other words, 2 pi is the same as 6 pi thirds. Now, on this, we have 13 pi thirds, and so we want to subtract 6 pi thirds, and so then we get 7 pi thirds. Now, 6 pi thirds was the revolution around because that was what 2 pi was, and so we've got to subtract it again. And so then we get pi thirds. So in other words, if I counted, okay, we're with 3 as the denominator. 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds, 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, 11 pi thirds, 12 pi thirds, 13 pi thirds. So I hope you saw that with my pen, and so pi thirds is like equivalent to 13 pi thirds. And so we get this ordered pair, which is a half with square root of 3 over 2. Now, since we want tangent, it's y over x, and so square root of 3 over 1, because your 2's cancel, and so that's just square root of 3. So this whole thing, this topic of periodic, just means it repeats. And so on these, on question 2, we had to do like 2 revolutions just to get to where it was. Okay, so now on this one, it's more like that question, where are you? So if we want sign positive, it's got to be up here. Sign positive means y positive. And for the other part, I'm going to say tangent positive is there and there. And we want tan and cotan to be negative. So that's going to be in here and in here. And if you think of like the overlap, it's going to be right there, which is in quadrant 2. Now, if you prefer doing it on the same graph, you can. You could have just said it's like this, and then it's this one also. Because sign positive meant it's there and there, and the other one like there and there. And so the darkest one is where it is. And it goes 1, 2, 3, 4. Okay, now this one is cosine is negative, which means x is negative, so it's one of these. And again, we want cotan negative, which would have to be this top quadrant again, because cotan is positive there. Now, when y'all do your question, it's probably not going to have quadrant 2 to be the answer for both of them. It's going to change these trig functions that it's asking about. or it's going to make a greater than instead of a less than or something. It's going to do something. So you need to remember where things are. So overall, like for reference, all are positive in 1, and in 2, that's where sine is positive and cosecant is positive. On 3, that's where tan is positive and cotan is positive. And on 4, that's where cosine is positive and secant is positive. And just assume all others are negative. When I do that, I don't want to make it too cluttered, but this one would have 0 negatives. This would have 4 negatives, 4 negatives, and 4 negatives. So it depends on like what function you're talking about. Okay, now this one we want cosine positive and secant negative. Well, since secant equals 1 over cosine, or you could think cosine is 1 over secant, it doesn't exist. Okay. Basically, we're saying cosine is positive, which is on the right. Secant negative would be on the left, and there's no overlap. So it's like undefined. Now on this one, we have secant negative, which is like over here, and we have sine positive, which is up here. And so our answers are right there, which is in 2. It's random that our answer's been 2 a lot. I mean, they could have easily made it something else. Now, on this question, you're trying to find the tan. And so you do this one divided by that. Wait, you do sine over cosine. This case, they put the sine first and the cosine second. So make sure you go that way. So it's going to be 6 square root of 37 over square root of 37. And so that's 6. And then the cotan is 1 over tan. And so it'd be 1/6. Because you think that's x over y. Because the first one was y over x. And on this one, you want to flip sine. The easiest way, like we've said before, is think of it as 6 over square root of 37, and then you flip it. Meaning flip the numerator and denominator. Don't flip the sign to negative. We just mean change your numerator and denominator. If you can visualize that, you're one step ahead. If you can't, that's okay. Start with 37 over 6 square root of 37, and then multiply by square root of 37 over square root of 37. And then this turns into 37 square root of 37 over 6 times 37, and then those cancel, so you get square root of 37 over 6, which is what that is. It is a lot easier if you can just say, well, if it's a square root and a number of the same thing, then it was originally this, and then flip it. So if you can eventually get to that point, it's going to be faster for you. The main thing is they don't want decimals. No decimals. On this one, it's 1 over cosine, so flip cosine. And so you just have this, which you'd think originally was 1 over square root of 37, and then flip it. Or if you want to take it a little bit slower, you have 37 over square root of 37, and then multiply by square root of 37 over square root of 37, which gives you 37 square root of 37 over 37, and then that cancels. So then you have square root of 37. So that's how all that works. Now, on this question, what we do is we first see what quadrant they're telling you. Sometimes they tell you the quadrant, like specifically in words, and sometimes they tell you two features and you got to figure out what quadrant you're in. So let's start with this one. If we're in quadrant 2, then we draw our triangle like this. And the way it works is this is quadrant 2. Your opposite would be here, your adjacent would be here, your hypotenuse would be here. Remember from what I said on 6.2, the slanted one is never negative. And so that means this is -4 for the adjacent, and this is 5 for the hypotenuse. Now, based on that, you can do your Pythagorean theorem, or in this case, a common right triangle would be 3, 4, 5. And 3 would go here. It is up 3, so that's why it's positive. Now, if you don't like that, then call it y and say y squared plus -4 squared equal 5 squared. So that means y squared plus 16 equal 25. Y squared is 9, so y is plus and minus 3. And in this case, we want up. So we want positive since it's up. So that's what's up. So then for your sine, I know before we said it's y, but it's also called opposite over hypotenuse. So that's 3 over 5. And then for tangent, it's opposite over adjacent. So that's 3 over -4. But we usually just put the negative sign in front. And then this one is 1 over tan. So it's -4 over 3. This is 1 over cosine. And so -5 over 4. And this is 1 over sine. And so 5 over 3, because we're flipping that one. Then on this one, we know cosine is 1/4. And we know cotangent is less than 0. Let's start with the cotan less than 0 part. So if cotan is negative, then that means you're either in this quadrant or this quadrant. That's where cotan is negative, in 2 or 3. I'm sorry, 2 or 4. And if cosine is 1/4, then it'd have to be like somewhere to the right, which is in 1 or 4. And between these, the 1 over 4 is the winner. So you're going to be over here. The hardest part is really knowing where you are. What quadrant are you in? And again, we said the hypotenuse has to be positive, and this is considered the adjacent, this is the opposite, this is a hypotenuse. So when you're in quadrant 4, that's what it looks like. And so this one, you're going to have to do your Pythagorean theorem. Cosine is 1/4, so like that. I'm again going to call it y. Make sure you put a negative sign. Once you're done, it's got to be negative because it's below. So we say 1 squared plus y squared equal 4 squared. 1 plus y squared equals 16. So then you get 15. So plus and minus square root of 15. And we say use negative square root of 15 since it's in 4, or since below. Okay. Now that you have that number, I'm going to put that over here. And for sine, it's opposite over hypotenuse. I'm just going to put O over H. Now it's wanting cotangent next, which is kind of random. I'm sure on Math Excel you have to go in a certain order. What I would do on this one is I'd say tangent is opposite over adjacent. I'm going to make it really obvious. OPP over ADJ. So that means cotangent would be ADJ over OPP. So the adjacent part, which is 1 over negative square root of 15. And then you rationalize it. We don't mean justify, we mean put the square root on top and on bottom. And so then we get negative square root of 15 over 15, which is what that is. Okay, so these are just jumbled in a random order. This one's tangent, and you notice it did say it's less than 0, so that's how you can say, oh, I knew it had to be negative. But this one's tangent, which is opposite over adjacent. And so think of like flipping this, and so it's negative square root of 15 over 1, which is negative square root of 15. Then for this one, you flip 1/4, it's 1 over cosine. Or if you want to work it out, cosine is adjacent over hypotenuse. And so that means secant is hypotenuse over adjacent. And so it's 4 over 1. Because here's your hypotenuse, here's your adjacent. Think of like adjacent touches the angle. You have your hypotenuse and it's like right there. It's always on the x-axis. ADJ is always on the x-axis. Okay, and then for this one, it's cosecant, which is like 1 over sine. We said sine was opposite over hypotenuse, so cosecant is hypotenuse over opposite. And so this is 4 over negative square root of 15. And then we rationalize that. And then you get negative 4 square root of 15 over 15. So there's that. Okay, on this one, we know secant is 7, which means cosine is 1/7, which is like that answer. Because remember, they're inverses. Cosecant negative means sine is negative. Sine is negative means down here somewhere. And if cosine is positive, then you're going to be here. So let me just draw it like that. So then this is your adjacent, this is your hypotenuse. This is your y, which has to be negative. And so we say 1 squared plus y squared equals 7 squared. 1 plus y squared is 49, and then that gives you 48. Now, when you have a number like 48, you're going to want to split it up. We can say 4 times 12, and then we can say 4 times 3. And so that's a pair of 4s, and so it's 4 square root of 3. That's the easiest way. It really is. But if you don't do it, you could say 24 times 2, and then that's really 12 times 2, 12 times 2 times 2. Then you can say that's 6 times 2 times 2 times 2, and then 3 times 2 times 2 times 2. I know this is kind of like unusual and it's a lot of parentheses. Oh, I left one out. I needed one more. So there are, it's like 3 times 2 to the 4th, because that's like 3 times 16. It's another way to think of it. And then the square root of 3 times the square root of 16, so that's 4 square root of 3. These are just different techniques. The main thing is you need to get it in simplest square root form, because it would be wrong if not simplified. Simplified. Which means the smallest one possible. So, for example, if you had 2 square root of 12 or something like that, that'd be counted wrong. They want it to be simplified, just like you simplified your fractions. So with all that being said, if this is 4 square root of 3, but then it's got to be negative based on where we are, then here's your angle, this is your adjacent, this is your hypotenuse, this is your opposite. So you're doing negative 4 square root of 3 over 7, because that's the opposite over hypotenuse. And this one we know was the adjacent, which was flipping sine. I'm sorry, or flip secant. This one, what you do is you cancel your 7s and you do negative 4 square root of 3 over 1, because that's like your opposite over your adjacent, OPP, ADJ. Then this one you flip it, and so it's 1 over negative 4 square root of 3. Now, by the way, at that particular step, if you want to try it on Math Excel, I know on 6.2 at least, it counted it right on Math Excel. But if you're trying to match the paper, you got to continue. So then we'd have to say negative 1 over 4 square root of 3, rationalize it, so we have square root of 3 over square root of 3, which gives us negative square root of 3 over 4 times 3, because if you have 2 square roots, it gives you the number. And so this would be negative square root of, I was about to put 13, negative square root of 3 over 12, which is what they have here. And then this is flip sine. So you have negative 7 over 4 square root of 3, which you could probably just count it right or continue. So you have negative 7 over 4 square root of 3, and then you do your square root of 3 over square root of 3, which gives you negative 7 square root of 3 over 4 times 3. So that's negative 7 square root of 3 over 12, which is that. So that's how those work. Now in this one, it's about an even and odd property, and I know I haven't talked about that yet. So here's your discussion about that. So say you're doing cosine, and you know it's positive, and then you're doing cosine again, and it's down here, and it's still positive. Now what that means, if I call this theta, this would be negative theta. What that means is cosine of positive theta is the same as cosine of negative theta. But when you do sine that way, sine would be positive here, and we're calling that theta. But when we go to negative theta, like backwards the same amount, you're now below the axis, and so sine would be negative. So that means that sine theta is negative sine of negative theta. It's like you got to do a double negative. So what we do on this is we say negative pi fourths is equivalent to 7 pi fourths, because you go backwards by pi fourths. You remember what I said before is you can go forward pi fourths and then flip, you know, if you want to do it that way. So that ordered pair is the square root of 2 over 2 for this one, and negative square root of 2 over 2 for this one. So since we're dealing with secant, we care about cosine, which is this one. So if cosine is square root of 2 over 2, which was really 1 over square root of 2, then secant is flip that, so it's square root of 2, because you just flip it upside down. Now this one's a little bit strange. 12. Okay, there's more. Some of these are easy, some are not. Okay, so let's work through this. What I'm thinking about is we're going backwards a little bit. Here's where 0 is, which is also where 2 pi is, which is also where 28 pi over 14 is, because 28 over 14 is 2. So if we're going backwards, you know, that tangent would be like some negative number. And positive tan of 29 fourteenths would be in, okay, 29 fourteenths, all the way around and then a little bit up. So tan of 29 pi over 14 would be a positive number. And then you're saying like a positive times a negative. And so we're getting negative 1. There's probably a better way. I know one way would be use your calculator, even though it says not to. And so let's show that. Use radians. So if we're in radians, we want cotan negative pi over 14 times tan of 29 pi over 14. and you get -1. So if you use your calculator, that does work out. So basically, this one is below, and this one's above, and we got 1. So it was actually -1 because you have a +1 times a -1. Okay, I'm actually going to stop the video there. I see how long the video is, and I might get to a better explanation of that. So let me just pause right there. Okay, hope you have a good day. Hope this helps.